All right, completing the square. First example, solve x squared plus 10x plus 5 equals 36. Completing the square is the method we're going to use to solve these quadratics. We don't need it in the first example because the left side is already a perfect square trinomial. You should be able to recognize that. How do you recognize if a trinomial is a perfect square? What do you look for first?
C is a perfect square.
C and A must both be perfect squares, which they are in this case. So this goes back to the factoring section. We know to factor this left side, x squared plus 10x plus 25, to x plus 5 squared, because of this being a perfect square trinomial. Don't mess with the 36. From here, how do you get rid of squaring something?
Square root.
Square rooting is the opposite of squaring. So when I take the square root of the left side, I get x plus 5. Square root of 36 is plus minus 6. And subtract 5 from both sides. So your two possible answers would be negative 5 plus 6, which is 1, or negative 5 minus 6, which is negative 11. If I plug in both of these into the original, they will both
So you
work.
just leave out the 10x.
Well, the 10 is in there. If you were to write this out twice, x plus 5, and FOIL it, then there's the 10x.
So you do
When
plus
you do
minus
the O and the I. What?
You do plus minus when you have a square, like when you do square root.
Yes, because when I square 6, I get 36. When I square negative 6, I get 36. So yes, plus minus always. Okay, does everybody have that one now? All right, the next example talks about how it'll give you, before I show you the next example, it would give me something like x squared plus 10x plus blank. What does that blank have to be to make it a perfect square trinomial? You got to be able to tell me it's 25. So how do we get that? Does anybody have an idea?
What?
Yes.
Yes.
No. The steps are to take your b value, which in this case is 10, divided by 2. What's 10 divided by 2?
5.
5 squared is 25.
That's
So
it.
the steps are to take b divided by 2 squared. All right. So the next one.
So wait, whoa. If it was x squared plus 4x plus 4 equals whatever, it would be x plus 2 squared?
Correct. Because you
Okay.
take b divided by 2.
Yeah.
Correct.
So it's always going to work with b and c.
Correct.
I don't understand that.
Thank you.
All right. So right here, it's easy to tell what that. Where's the remote? It's easy to tell what the c value has to be if you divide evenly. So the first one, what goes in the blank? You take b, negative 8 divided by 2, which is negative 4. Negative 4 squared is positive 16. That makes it a perfect square trinomial. Now here, when you take 7, don't change it to a decimal, leave it as a fraction. 7 divided by 2, you can't do anything with it. Square it, you get 49/4. That's it. That makes it a perfect square trinomial.
Are we going to have questions like that on the test?
Yes. Yeah.
When you do negative 4 squared.
Well, that's easy. I mean, if you remember this formula, b divided by 2 squared, you're set. What?
When you do negative 4 squared, isn't it supposed to be negative 16? Not positive?
No. This number over here will always be positive. Because whether you square a negative or a positive, you end up with a
You're
positive.
gonna give us.
So that's all we got to remember is the over 2 squared.
You're gonna give us
Right.
all the formulas for this.
Yeah. Okay?
But whoa,
What?
wouldn't it be x, for the first one it'd be x minus b over 2 squared? Because the x is in there, right?
No, to find your c value, you just take b divided by 2.
Okay, gotcha.
And b in the first one is negative 8. Divided by 2 is negative 4. Negative 4 squared is 16. All right? Next.
Why does C always have to be positive?
Because whether you square a negative or a positive, you end up with a negative. Or I mean a positive, sorry. When you
But-
square a negative times a negative is a positive. when you square a positive. A positive times a positive is a positive.
Yeah, but you know when this is like -4 squared and it comes out -16,
Positive 16.
but like without the parentheses around.
Then it would be -16, but that's not what you're doing here. You're squaring -4, which means -4 times -4. Okay? Next one.
Whoa.
This one's solve x squared minus 12x plus 5 by completing the square. Alright, so the first thing you need to do,
Wait,
this is not a perfect square trinomial over here. So we need to get, when we use completing the square method, we have to have a perfect square trinomial on the left-hand side.
Wait, how is it you know that it's perfect square?
You look at the first term and the last term and determine if they're perfect squares. 5 is not a perfect square, so you know right away that it's not a perfect square trinomial. So we have to get the x's by themselves, so I subtract 5 from both sides, so I get x squared minus 12x equals -5. Now I'm going to make the left-hand side a perfect square trinomial, just like I did in the previous example. Take your b value, which is -12, divided by 2, which is what? -6. -6 squared is 36. So I'm going to add 36 to this side to make it a perfect square trinomial. If I add it to one side, I have to add it to the other side, so I'm not changing the problem. Okay? Everybody follow me up to this step? Then all I do is factor the left side. It's a perfect square trinomial. It's x minus, since this is minus, this has to be minus, and the square root of 36 is 6. So x minus 6 squared equals 31. Yeah?
Could you have plugged in any perfect square?
No. It has to be b divided by 2 squared.
Oh, okay.
-12 divided by 2 is -6. -6 squared is 36.
Wait, how did you get?
Whatever you do to one side, you have to do it to the other, so you're not changing the problem.
How'd you get the x minus 6 squared?
This is the perfect square trinomial formula. The square root of x squared is x. The square root of 36 is 6. And since it's minus here, it has to be minus here. Okay? And then you take the square root of both sides, so you get x minus 6 on the left, plus minus square root of 31 on the right. You don't mess with this unless it asks for decimal form, but I don't think it does. So just leave it as square root of 31. Alright, and now if it can be simplified, you would do that, but 31 cannot be broken down. And then just add 6 to both sides and you're done.
Would you do
6 plus minus square root of 31.
would the number that doesn't have a radical on it always go first?
Yes, that's standard form.
Wait, why'd you have to? Oh, never mind.
Yes?
So we were to simplify. If 31 could have been simplified, we would simplify it to radical form.
Yeah.
But why'd you say like the minus is because you have x squared minus 12? Why'd you say in x minus 6? That's because that's what
The sign inside the parenthesis is always the same as your b value. Since your b was negative, this has to be negative. Alright, next. Same type of problem. Again, get the x's by themselves.
Is 36 a perfect square?
36 is a perfect square, and x is a perfect square. But this is one of those that I was talking about that they might try to trick you, because if you were to take the square root of 36, it'd be x minus 6 squared, right? And if you were to FOIL that out, you would get 12, not 8. So you gotta be careful.
Whoa.
You gotta be careful. This is not a perfect square trinomial just because the first and last are perfect squares. Because if you were to use our rules, you get x minus 6, and x minus 6 squared would be x squared minus 12x.
So before you
Why
even
would they do
solve,
that to
you
us?
have to figure
You
out.
need to
if it's
check it
perfect.
to see.
No.
So, well, the safe thing to do is just go ahead and go through the steps anyway. You can't go wrong by going through the steps. So subtract 36. Take your b value divided by 2. Squared is 16. Add 16 to both sides. You end up with negative 20. And the square root of a negative number, you got to pull the I out, right?
Whoa.
So you take the square root of this, you get x minus 4 equals plus minus I root 20. The 20 breaks down to 2I root 5. So your final answer is x equals 4 plus minus 2I root 5.